Morning children, now we are going to discuss about limiting friction, angle of friction, and angle of repose. So the first one is limiting friction. When an object is placed on a rough horizontal surface, the force is applied, means F applied. Then this is force of limiting. When force of limiting is F applied is maximum, then F applied is equals to force of limiting. Then normal force is acting upward direction, then weight is always acting vertically downward direction. F applied is maximum, means the object is ready to move, then that force we call it as force of limiting static frictional force is equals to F applied, that is the maximum force applied. F applied maximum is equals to limiting static frictional force. Here the object is in equilibrium condition. Equilibrium means object is at rest, just ready to move. Then F applied is maximum. That we call it as Fs limiting. Then here normal force is equals to weight mc. This we call it as reaction force. Means what is a reaction force? So here this reaction force is making an angle theta with normal. The reaction force is making an angle theta with normal. Therefore, this reaction force is resolving into two components. One is R cos theta is equals to N. Another one is R sin theta is equals to F. This reaction force only resolving into two components. One is normal, another one is parallel. One is perpendicular, another one is parallel. So here from these two, tan theta is equals to F by N. Then what is F? Static frictional force. Fs by N. N and get cancel. Then tan theta is equals to mu s. Here theta is equals to tan inverse of mu s. This theta we call it as angle of friction. Angle of friction theta is equals to tan inverse of mu s. Are you clear here? Angle of friction tan theta is equals to mu s. Now here the reaction force Fr is equals to root over Fs square plus N square. Here N is taken as the common root over mu s square plus 1. Here N into, because of y N is taken common, Fs is equals to mu s into N. Already previous class we discussed. Mu s, N square is taken as the common, N root over mu s. Mu s is nothing but what is tan theta. Means like tan square theta plus 1, that is equals to N into tan square theta plus 1 is secant theta. means tan square theta plus 1 is equals to secant square theta. Secant square theta, square will get cancelled, secant theta. Therefore here F reaction force means Fr. So this one is Fr reaction force. Fr is equals to N by cos theta. N by cos theta. Here N is nothing but what is N? Object is placed in a rough horizontal surface. Object is placed in a rough horizontal surface. That is equals to mg by cos theta. Fr is equals to mg by cos theta. This is normal reaction force. So what is the angle of friction? Angle of friction is equals to mu is equals to tan theta. And next one is angle of repose. Angle of repose. Angle of repose means when an object is placed on an inclined plane, on an inclined plane, on an inclined plane, on an inclined plane of inclination is alpha. Of an inclined plane of inclination is alpha. Here object is like this. This is the normal force and this one is frictional force. Frictional force means like this is the frictional force, force of friction. For this one is mg sin alpha. For this one is mg cos alpha. The angle of repose is nothing but where an object is placed on an inclined plane of inclination. Suppose angle of inclination is theta. When we increase the angle of inclination like that, suppose see this hand, first basically is there like this. Whenever the object is just ready to move on the surface of this, that angle of inclination we call it as angle of repose. Now suppose first you are placing the inclined plane like this, it makes an angle theta. Object is placed on the inclined plane surface, object is not ready to move. When we increasing the angle of inclination like this, the object is ready to move, then this corresponding angle of inclination is called angle of repose. Corresponding angle of inclination is called as repose. Now here this is a concerned with an angle of inclination which the body rests exerting its weight on the plane. Angle of repose is nothing but this is the concern with an angle of inclined plane on which the block rests exerting its weight on the plane. Weight on the plane. Here Fs is equals to what is Fs? mg sin alpha. Fs is equals to mg sin alpha. Means the object is at rest. Here object is at rest. Fs is equals to mg sin alpha. N is equals to mg cos alpha. Sorry, angle of repose means the object is at rest. Object is at rest. The corresponding angle of inclination we call it as angle of repose. Fs is equals to mg sin alpha. Then here Fs is equals to mu s into n. N means mg cos alpha. Therefore mg sin alpha is equals to mu s mg cos alpha. Mg get cancelled. Then tan alpha is equals to mu s. Tan alpha is equals to mu s. Tan alpha is equals to mu s. This is angle of repose. Angle of repose. Children, here initially the object is at rest on this surface. When we increase the angle, the object is ready to move. When we increase the angle, mg sin theta increases, Fs is decreases. Means like the object is ready to move. Then the corresponding angle of this we call it as angle of repose. First one only we said correctly. See here, the angle of inclination is increases, then mg sin alpha increases, then fs maximum decreases. The corresponding angle we call it as angle of repose. Now we are going to discuss static and kinetic regions. Static and kinetic regions means, see here, when we draw the graph between applied force and frictional force, F applied and this one is force of friction, F applied is capital F applied. For this, this one is completely static region. This total the static region. And suppose this also static region only, Fs. This is Fs limiting. Suppose this is static region. Up to Fs limiting, applied force 1 Newton means force of friction 1. Applied 2 means force of friction is 2, means like a straight line. Up to that means up to it reaches a maximum limiting, means like this is the maximum limiting region. For this is kinetic region. For this total is the kinetic region. For here, for this point 2. For this point 2 means like this total is the static region. This total is kinetic region. This is the graph when we draw the applied force and force of friction. So when it reaches the maximum limiting, up to that, static frictional force is equals to applied force. After that, kinetic frictional force is a constant. Whatever the speed of the object. Now here, the coefficient of friction depends on strength of the molecular interaction between the surfaces in contact. First point is, the coefficient of friction depends on strength of the molecular interaction between the surfaces in contact. And second one is roughness of the two surfaces. The force of friction will depends on roughness of the two surfaces are in contact.